This video is about compound inequalities. Compound inequalities occur when you have two or more inequalities that are joined by the word and or the word or. So the word and requires that both of the conditions must hold. As an example, if I say Dan and Harland are taking art, that means that both Dan and Harland must be in art. If only one of them is taking art, then this statement is not true. On the other hand, or means at least one of the conditions hold. So I could say Dan or Harland is taking art, and that doesn't require that both of them are in there, only one of them. If Dan's taking art but Harland isn't, that's okay. That's still a true sentence. Could Dan and Harland be taking art? Certainly, because still at least one of those is true. So what does it look like when we're looking at a mathematical inequality? Here's the compound inequality: x is less than 5 and x is greater than or equal to -3. When we look at compound inequalities, it's easiest to look at the graph on a number line. When I graph it on the number line, I'm going to graph both of the conditions on the same number line. So I'm going to start with x less than 5. Notice that the circle around 5 is a white circle. We know x less than 5 means that I have an open circle at 5. The way it's going to work, we're going to have a white circle on the open circles, and we'll have a colored circle on the less than or greater than or equal to. So here we have all of the points that are less than 5 shown in the blue. And I'm going to show you x greater than -3, greater than or equal to -3, just on another number line so you can see it. But typically we don't do that. We graph it right on top of the other one. So now we need to figure out when are the two conditions, x less than 5 and x greater than or equal to -3, true. And we're going to do that partially by looking at points and seeing what makes whether the points are true or not. So if I look at the point x equals to 7, I'm going to substitute 7 into both of the inequalities to see which one it makes it true, or that it makes both of them true. So if I have 7 less than 5, is that true? Well, it really isn't. How about 7 greater than or equal to -3? That one is true. But both of them aren't true. And with an and, they both have to be true for that condition, that inequality to be true. So this is not, this point, x equals 7, is not on my solution. Let's try a different point. Look at x equals -4. If I substitute -4 in for x, is -4 less than 5? Yes, that's a true sentence. How about -4 greater than or equal to -3? No, that one's not true. So again, this -4 is not in my solution to the compound inequality. Well, let's look somewhere in between. So let's look at -1. If x is -1, is -1 less than 5? Yes, that's true. How about -1 greater than or equal to -3? That's true also. So the area in between the 2 points, and that's really where those two graphs overlap, 5 going to the left and -3 going to the right, where it makes those two inequalities true. So my solution are all of these points in the yellow that you see below. We can write that in combined form like the blue down here, or you can write it as we did above. If you write it in combined form, you would read that as x is greater than or equal to -3 and is less than 5. You could also read it as -3 is less than or equal to x, which is less than 5. And you can also say x is between -3 and 5, including -3. Now let's look at another example, this time with an or. I'm going to graph both x greater than 5 and x less than or equal to -3, and I'm going to look at where the solution to the compound inequality is on the graph. So I'm starting with x is greater than 5. Remember, open circle around 5 shows up as a white circle, but it's an open circle around 5 going to the right. X less than or equal to -3 is a closed circle at -3 going to the left. Remember, we really don't make the two lines when we graph. We really just put everything on one. And so now this is the two graphs. Where in this graph does it make that compound inequality true? Well, let's take some points and see. I'm going to start by looking at x equals -1. Does x equal -1 make at least one, because it's an or, at least one of the inequalities true? So is -1 greater than 5? No, it's not. How about -1 less than or equal to -3? That's not true either. So that area between the 2 points is not going to make this inequality true. Let's try something on the other side of the point. So let's try x equals 6. Is 6 greater than 5? Yes, it is. How about 6 less than or equal to -3? No, that's not true. But remember, this is an or. The conditions for or was that at least one makes it true. One of these does. So where x equals 6 is sitting, that blue part of the graph is part of the solution to my compound inequality. What about on the other side? Let's try -4. So if I put -4 in, is -4 greater than 5? No, it isn't. How about -4 less than or equal to -3? That one is true. So that means that that red area is also part of my inequality. So my solution is the two branches of this graph, where x is greater than 5 or x is less than or equal to -3. I could also write it as -3 is less than or equal to x, or x is greater than 5. Here's another example. Let's look at x greater than 5 and x greater than or equal to -3. So I'm going to graph it. Again, I'm going to start with x greater than 5, open circle at 5, going to the right. Here's x greater than or equal to -3. Remember, we don't really put them on two graphs. We put it on one graph. And now I need to figure out where on this graph those two compound inequalities make the equation true. So I'm going to start with this point here, x equal -1. Is -1 greater than 5? No, that one is false. Is -1 greater than or equal to -3? That one's true. But it's an and that means both of these inequalities need to make it true. And it doesn't. So this point is not part of my solution. What if we try over here at 6? Is 6 greater than 5? That's true. Is 6 greater than or equal to -3? That's true. That means that my solution is that area from 5 on, and where you see on the yellow graph. Now, if you think about what's going on, that area is where the two, the red graph and the blue graph, overlap. So we can see when we're talking about and, we want to have where both parts of that graph occur. If we don't have where both parts of that graph occur, then it's not going to make both of those sentences true. So my solution for this inequality is x is greater than 5. So let's recap for a second. What's important when you graph compound inequalities is that you actually graph them. Don't try to figure out the solution without graphing first. Once you've graphed it, decide whether your statement is an and or an or, so that tells you whether or not it's both conditions or just one of them. And be sure to look carefully at the graph to make sure that you have the right solution. Also, remember to write the correct solution down, like we did here, x greater than 5. Don't make the reader guess what your solution is based on what your graph looks like. Okay, that's it for right now. We'll have some practice problems for you where you get to think a little bit about how these graphs work. Remember, if you have any questions, see a math teacher.